Hello everyone, this is lesson 7, scale factor and similarity review for the midterm. So we just done this unit, so hopefully it's fairly familiar. We're going to talk about scale factor first, and the big thing about scale factor is when you calculate it, you want to calculate the image and divide it by the same side length on the original. And remembering what represents the original is just going to be A, B, C, D, or whatever letters. And the image is going to be A prime, B prime, C prime, D prime. So if you see the little apostrophe, that means it's the image or the thing that it's changed to. So this first one, we need to just decide about two similar sides. So for example, from A to B, and we're also going to, from A prime, B prime, and we're also going to compare that from A to B. Well, from A to B, if you count it up, you're going to get 12. So the distance here is 12, okay? And from A prime to B prime, the same corresponding side, the distance is 6. Well, to do the scale factor, you're doing the image divided by the original. Sorry, I'm all over the place here. So scale factor is the image divided by the original length. So in this case, the image length that we chose was 6, and the original is 12. So 6 over 12 can reduce to 1/2. Okay, so the image is 1/2 the size of the original. And that would mean that it's a reduction. So let's do the same thing here. We're going to pick two corresponding sides. So AD is pretty easy to pick, and A prime, D prime. So A prime, D prime looks like it's a distance of 10, and AD is a distance of 2. So the scale factor is going to be the image, which is 10, divided by the original, which is 2. And this can reduce to just 5. So this means that it's an enlargement. An artist painted a picture of the Eiffel Tower. The Eiffel Tower is 325 meters high. So the actual height is 325. The artist used a scale factor of 1/25. So if we think about what this means, this is the image, and this is the original. And we are looking for the image height. That's our unknown. So if we start with our unknown, the image height, call it x, and divide that by the actual height, 325, we can set that equal to our scale factor, 1/25. And if you recall how you solve these, you can multiply each side by both or by the unique denominators and see what will simplify. And in this case, on the right side, the 25 simplify, and on the left side, the 325 simplify. So I'm just going to bring this up here, a little bit more room. So you end up with 25x is equal to 325. And if you go ahead and divide by 25, x will equal 13 meters. So, therefore, the image height is 13 meters. All right, a boat can travel 320 kilometers on 64 liters of gasoline. How much gasoline? That's our unknown, so let's call that x. Will it need to travel 405? Let's start with our unknown, divide it by the number of kilometers we want to travel, and set that equal to the other information. So the liters goes on top, and the amount of kilometers goes on bottom. Now, solving this, if you multiply each side by the unique denominators, you can see that on the right side the 320 simplifies to 1, and on the left side the 405 simplifies to 1. So you're going to be left with 320x is equal to 64 times 405. Now I can't do this in my head, so let's get our calculators out. So 64 times 405 gives us 2005,920. And then go ahead and divide by 320. And x equals 81. So, therefore, the boat needs 81 liters of gas. All right, determine whether the polygons are similar. So if you want to figure out similar, you're going to compare corresponding sides. So in this case, 8 and 12 are similar sides, and 6 and 8 are similar sides. So you can compare. Let's start with 8 and divide it by its corresponding side. And let's see if that equals 6 divided by 8. Okay, so 8 and 12 we're going to compare, and 6 and 8 we're going to compare. So the left side here works out to 0.66 repeating, and the right side works out to 0.75. Well, is 0.66 the same as 0.75? They're not equal. Therefore, these two are not similar. Let's do the same thing on the right side. First, we need to figure out which sides are corresponding. So 14 and 1.5. 14 and 3.5 are similar, and 6 and 1.5 are the corresponding sides, I should say. So let's compare our two fractions. So starting with 14 over 3.5, and let's compare that to 6 over 1.5. And if you divide both of these, you actually get 4 equals 4. And 4 does equal 4, so therefore, these are similar. We're going to use proportional reasoning to determine the unknown. So in this case, the unknown is m. So start with your unknown. And what side on this shape is the same? And it appears to be 12. So we're going to put m over 12. Now we just need to pick two other corresponding sides. So 15 and 10 are corresponding sides. So 15 over 10. Now solving this, if you multiply this side by 12 and by 10, and this side by 12 and by 10, 12 simplify, the 10 simplifies. So you're left with 10m is equal to 15 times 12. So 180. Therefore, m is going to equal 18. Doing the same thing on this side, we need to figure out corresponding sides. Now, you'll notice that these little markers, they're not kind of in the same orientation. So you have to be careful about which sides you're choosing are corresponding. So the unknown here, let's start with x. Let's figure out x. So x over, what's its corresponding side? Appears to be 6. Okay. And the only sides that we have both information for are sort of the vertical sides. So 6 and 3. So x over 6 is equal to 6 over 3. And in solving this, we're going to get x is equal to 12. Okay. That's one side. Now we also need to figure out y. So y over 9 is equal to 3 over 6. And if you multiply each side by the denominators, you're going to get 6y is equal to 27. Therefore, y is equal to 27 divided by 6, which is 4.5. Stephanie casts a shadow of 1.2 meters, and she's 1.8 meters tall. So let's draw this situation. So the shadow is 1.2 meters, and she's 1.8 meters tall. And we're also comparing this to a turbine, a wind turbine. So that looks like that. So the turbine has a shadow of 10 meters, and we want to figure out its height. So start with its height over the corresponding side, which is Stephanie's height, so 1.8, and compare that to 10 over 1.2. And if you solve this one, multiplying each side by the two different denominators here, you're going to get 1.2x is equal to 18. And dividing each side by 1.2, you get x is equal to 15 meters. Therefore, the turbine is not 18 meters tall, 15 meters tall. Tanya is 1.3 meters tall. She stands in front of a tree that can cast a shadow 2 meters long. How tall is the tree? Well, let's just fill in some information here. So this height is going to be 1.3. She's standing, her shadow is 2 meters long. So that goes from there to there. And she's also standing 7 meters away, and we're looking for the height. So if you notice, we kind of have two triangles going on here. We've got this little triangle, and then we've also got the big triangle. So I'm actually going to just separate those two. So the big triangle and the little triangle, so 1.3 and 2 is a little triangle, and x, and this is actually going to be 7 plus 2, so the total distance is 9. So let's set up a proportion statement here. So x over 1.3 is equal to 9 over 2. And using the same methods that we've been using, x is going to equal 5.85 meters. So, therefore, the tree is 5.85 meters tall. All right, so then we get into lines of symmetry, and a line of symmetry separates a shape into equal halves. Okay, so this first one is a line of symmetry because this side looks exactly like this side but just flipped. Okay, this one is not a line of symmetry, the second example, because if you were to copy this shape, you'd actually end up with something more like this if you used this line as a line of symmetry. So it is not a line of symmetry. Drawing in the lines of symmetry and state how many there are. So we can start to see that there's going to be one going this way. And then there's a second one there. And then there's a third one. Run out of pen colors here. Let's go green. There's another one. Fuchsia. What haven't I used? Orange. And one more. Let's go. I don't know what color this is called. There we go. So that's all the lines of symmetry. So now we can count up how many there are. So starting at some color, let's start at the blue. So 1, 2, 3, 4, 5, 6, 7. And you'll notice that if I put an 8 here, it's actually the one we've already counted. So there's only 7. And in this one, there's going to be 1, 2, 3, 4, and 5. All right, we got to reflect GHI across the x-axis. So all you do here is you count how many down to the x-axis and then count the same number. So this is G prime. That's going to be I prime. And 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's H prime, and connect those up, and you've got yourself a new shape. Reflecting quadrilateral QRST across the y-axis, well, you count the number to the y-axis and then just count the same numbers. So there's R prime. S prime is going to be 3 away from the y-axis. T prime is also going to be 3 away from the y-axis. And Q prime actually stays right on the y-axis. Connect those up, and there's your shape. You can clean it up a little bit, but there's our reflected image. All right, reflecting KLM across the line x equals 1. Well, what line is that? And it's basically every x value. So where does every x value equal 1? Well, on the x-axis, that equals 1. But your x value is also 1 there, and 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 there. And there's actually an infinite number of points here. And what that does is it creates a line of symmetry, or a line to be reflected in. Okay? So instead of counting the number to the x or y axis, you count towards this line. So 1, 2, 1, 2. So there's M prime. 1, 2, 3, 4, 1, 2, 3, 4. There's L prime, and K prime ends up being down there. So then you can go ahead and connect these, and there is your image reflected in the line x equals 1. Reflecting UVW across the line y equals -1. Well, what does this mean? This basically means every y equals -1 point. So where does y equals -1? Well, right on the y-axis it does, but also here, and here, and here. All of these points have y being -1 as their coordinates, and you actually end up with an infinite number of solutions, which creates a line. So this part's not so tricky, but you count towards the reflecting line and then count the same number past that line. So there's 1, so you count up 1. So that's W prime. U prime, you're going to count down 2. And V prime, you're going 1, 2, 3, 4, 1, 2, 3, 4. So there's V prime. Let's just clean this up a little bit. But connecting these points now, you'll see that the shapes actually overlap. And that's okay, all right? The line of reflection actually cuts through the bottom of the original shape, so it makes sense that the reflected image actually has some above the line. So figure has rotational symmetry if it can be turned around at the center to match itself in less than a 360 rotation. So what does this mean? Well, if I just kind of trace, see how well this works on the iPad. Okay, I'm going to select that image. And what I'm going to do is I'm just going to kind of rotate it. Now, I got to be careful here because it changes the size, but I can rotate this image, and that's looking the same. And then I rotate it again, and it's back to the original. So this means it has order 2. And if we do 360 degrees divided by 2, that equals 180 degrees. So every 180 degrees, it looks the same. Now, again, I can kind of show you with this trick. It's not perfect, but so move it a little bit. That's going to look the same. I didn't trace it very well. That looks the same. That looks the same. That looks the same. And then we're back to the original. So how many times did it look the same? Well, that's 5. And then 360 divided by 5 gives us 72 degrees, is its angle of rotation. This one you could probably see is also is 4. Okay. And 360 divided by 4 is 90. And this last one has order 8, which means its angle is 45 degrees. I won't show you all the not a perfect drawing. Okay. But get it. Every time you kind of move one of those spokes, it should line up with another spoke and look the same. Okay? And if you do that 8 times, it works. Okay. Now these last two, we got to rotate around the origin. So if you recall, the origin is that point there. So there's actually a better video about how to do this in the previous lessons, but I'll kind of show you what this looks like. So what you do is you trace the image using tracing paper, and you also trace the origin point. And then what you do is you'd actually spin your tracing paper around, and keeping that origin on the origin, you end up with a shape down there, and I've made it a little bit too big. Whoop. But hopefully you can see that the new shape is going to have a point there, there, and there. And this is the rotated image. So V prime, X prime, and W prime. Now the last one is rotating around the point -1, 1, which is right there. So again, if you trace your image, let's be a little bit more precise here actually. Tracing that image and the rotating point, and we got to rotate it 90 degrees clockwise. So clockwise is going to rotate it around this way. Okay, so 90 degrees around that point gets the image being over in that quadrant. Okay, and you can mark your new points, and there's your new image.